Hi everyone, I'm Subaya. I'm an applications engineer here at Copper Mountain Technologies. In this video, I'll be demonstrating automatic fixture removal using Copper Mountain Technologies Vector Network Analyzers. AFR is an intuitive software plugin. It is used to accurately measure hard-to-access devices such as SMB-sized components mounted on a fixture by de-embedding its fixture effects. The user can select either time gating, filtering, or bisect methods on a full 2-port 2x2 fixture or a 1-port reflect fixture. By using one of these methods, this software plugin provides the user with accurate and reliable measurements of components being tested. Here is the user interface for the plugin. The plugin walks through various steps to perform the components measurements. The first step is describing the fixture. You have many options to select the type of fixture. The default setting is a 2-port fixture, so that's why you see number of ports 1 on fixture A side and 1 on fixture B side. But if you have a 4-port fixture to measure differential measurements, then you have the option to select more than 1 ports on each end. For the demonstration today, we'll be using a 2x2 fixture, so we'll select number of ports as 1 and we'll select both fixture A as well as fixture B. For the method, we have 3 different types of methods to choose from. First is the time gating. This uses traditional time gating algorithm. The second is the filtering method. This is an advanced time gating algorithm which uses LMS joint estimation in addition to the traditional time gating technique. The third step is the bisect method. Bisect does not use any time gating information. It simply bisects the fixture into 2 halves. And so in certain fixtures, you would see that bisect is more suitable if your fixtures are much smaller in size. The next step is to provide more details about the fixture. So you're looking at the 2x2 method. So you can choose whether the A and B are connected directly, or if you want to use the reflect method, so you can select, you can disconnect the connection here and then select the reflect method. So first we will look at the 2x2. So we'll enable the A to B connection. And next we'll configure the VNA setup. So this would really depend on the fixture's parameters. So let's say you have a 20 gig fixture here. So we have the start frequency from 10 megahertz to 20 gig in this case, and sweep points 201 because that's the default sweep points. But here you can adjust the sweep points. The plugin also recommends the best settings. So in this case, you see 201 because this is the default settings. So you can adjust the sweep points to the recommended value. So we can say 2000, and then now you can proceed to the next step. So you see all the error and warning messages are gone. And the next step, you perform calibration. Now the plugin detected that the VNA hasn't been calibrated. So the first step is to perform full 2-port calibration at the end of the cables. So at this point, you can go to the VNA software, choose calibration, and then select one of the various methods. So here you can use the mechanical or the automatic calibration module. And here today we have the ACM 2520. So we will go to AutoCal. The analyzer detected that the ACM 2520 is connected. So I'll go ahead and click on 2-port AutoCal to perform full 2-port calibration. All right, so now the calibration has been performed. So that's what here F2 indicates full 2-port calibration. Now we'll go back to the plugin, and then as you can see, the error messages are gone. So we'll go to the next step, and at this point you disconnect the ACM and connect your fixture. So now we have the fixture connected. We can go ahead and click on measure through. So once you click on that, the plugin will measure the through from the calibration plane. So now it's looking at from the end of the cables. And under edit characterization, we have additional information about the fixture. So here you can look at the length of the fixture, the various gating locations, impedance of the fixture, and the S parameters. Here you're looking at both fixture A and fixture B. So that's what it indicates when it says A for S11 to S22 and then B for the rest of the parameters here. So the one single fixture was split into two, and that's how we're able to separate the fixtures into two halves. Now we can proceed to the final step, and here we can click on apply. Once you click on apply, the de-embedding will be performed automatically. And there you go. So now you see de-embed applied here. This indicates that the de-embedding was performed successfully. And you can also add more traces and see how all the measurements look like. So you're looking at S11, S21, S12, and S22. As you can see, the reflection on port 1 side is pretty good, and so is port 2 side as well. And then the S21 and S12 are a very good flat 0 dB line. And you can also look at how the de-embedding was performed. You can go to analysis, fixture simulator, turn it off. So this is without de-embedding performed, and this is with de-embedding performed. So you can see that the AFR worked well for this fixture and all the way up to the stop frequencies. And the plugin also allows you to save the correction files for future use. So you can save the fixture files, and that saves it to a Touchstone file, and this is what you can use it later on as well. So far we saw the 2x through fixture. Now we will look at the 1x reflect fixture. So we will go back to the description and we will select the fixture here. So we will select just one fixture, proceed to the next step, and here you can see just select one and fixture A. The 1x reflect method is most suitable for pigtail or probe, which is more a single port fixture. So for these kinds of devices, you would select this method. And now moving to the next step, you see we had already adjusted the frequencies, so we don't have to mess with those settings again. So we'll go proceed. Even the calibration was performed. In this step, you can select the termination for the fixture. You can select either open or short, or a combination of both open and short to measure the fixture and de-embed. So here today we have the open termination, so we'll go ahead and click on measure. And once that open was measured, you can go to edit characterization, look at the length, gating, impedance, and S parameter for that one port fixture. And once we are satisfied with the fixture measurements, you can proceed to the final step and then click on apply. Once you click on apply, again you see the DMB applied for that one port fixture, and for S11 you see a flat 0 dB line, or in Smith you can add a marker and then you can look at a very good dot at 0 degrees. So this shows that de-embedding was performed successfully for the 1x reflect model as well. Thanks for watching. If you have further questions, please visit our website, or you can also email us at support@coppermountaintech.com. Thank you.